This is the tutorial for the terrain generation tool. So we'll start off with the basic controls. First of all, right click will let you rotate around the center point. Control and left click will let you move the center point. You can control both of these in the view on the right, the sensitivity. You can zoom with mouse wheel, and if you ever go too far out with your center point and can't seem to get your way back, there's a button on the right hand side that says reset camera rotation position. This will set it in the center of the model and make it easy for you to start work on it again. When using the sliders, sometimes you might feel like you don't get the ability to specify exactly the number you want. You can control and left click. This gives you the ability to set the value to whatever you want. Right, starting with the features, you have two terrain generation algorithms. You have diamond, square, and noise. Diamond square has two sliders. Detail, which affects the size of the model, more so the resolution. 9 detail is a 513 by 513 model, and 10 is a 1025 by 1025 model. Roughness determines how rough the terrain is. So the lower the value, the smoother it will be, and the higher the value, the rougher it will be. Okay, onto noise. So noise, as you can see, noise, I made it a bit too big. There you go. So noise is, imagine it as an image or static of sorts. You can see the noise representation in the height map image when you have one available. So that would be the noise. So by enabling multiple noise, you layer these on top of each other, as you can see. But let's say it doesn't look like you want. You can layer noise to make it appear more detailed. And so that is with the octaves. The higher the octaves, the more layers of noise you add, which will make it look more realistic. You have multiple values here to control the noise. The size, which controls the size of the noise model. Redistribution, which shifts the height values of each point to at the top or the bottom. So you'll see as redistribution goes down, it will shift towards the top and slowly flatten out. And the closer you go to 10, it will start going down. What you can do with that is make some, redistribute it just a little bit down, and you get more reasonable mountains and slopes and flat plains that you'd like. The height sets the height value of the noise. It is from 0 to the height, so 255. Turn this back to 1 so you can see it. Height will just scale it up, as you can see. Floor height does what it says. It raises the floor, so you can see the floor pretty much consume the model. On from that, you have the noise controls specific to each noise. The octave I explained already. You have new P seed and new C seed. That generates a new noise seed to change the noise that you have. The P intensity, or intensity in general, that only works when you have multiple noises enabled. What it does is it averages the noise, it averages the noise based on the weight of each noise that you're using. If you only use one, it uses 100% of that noise. If you have two and both are intensity of 1, it uses both equally. If I were to lower Perlin noise, it will use more and more of the cellular noise values as you get lower. But then you can do the same for cellular, where you lower the intensity and you get less and less of the cellular height in the actual map, but you get more of purling. The scale is, as it says, the scale, so it controls the how, imagine as zoomed in or zoomed out of the noise you are. So the smaller you go, the bigger it is, as you can see. But the bigger you go, it just scales up exponentially, really. So you want to come back down, and oftentimes you just want to stay low. On for that, we have the height map. It is just a representation of the height of your model onto an image that you can export and use. Hydraulic erosion. Cycles is how many raindrops it generates. You have hydraulic erosion that you can click to start it, and then it will erode the terrain. There you go. So now you can see it's eroded. And you can see, so what happens is the water drops, it takes some of the height value that it lands on and then brings it down and deposits it. You have advanced controls. You can see all of those along here and what they do. On to the right, you have the brushes. Start with the smoothing brush. You'd like to use this often with terrain when you use hydraulic erosion, because it allows you to smooth some of the jaggedness in the terrain. Make it slightly bigger. There you go. So you can smooth it out. So for the smoothness brush, the smoothness rate is a representation of how strongly it values the original height map and the surrounding ones. So the lower the smooth rate, the lesser impact surrounding vertices or heights have on that specific one. And the larger it is, the more aggressively it smooths. As you can see, it takes out any sort of detail in the terrain when you have it that high. Next, we have the flatten brush, which does what it says. It flattens. You have the size, the max height difference. So when you try and flatten on the side of a mountain, if a height is larger than 5, it will not flatten it. So you can change that. Smoothness affects how harsh it is when setting the values. A smoothness of 1 will just completely flatten the area, but a low smoothness of, let's say, 0.01 will be a lot more gradual in how it smooths, almost as the smooth brush, but it attempts to flatten it instead of smoothing the edges. Raised brush, like lower brush, adds to the terrain, so you can increase the rate to make it add more faster. And the raise strength, which at 1 predominantly raises the center point of the brush and gradually raises the points around it. But with a lower brush, it more evenly adds to the terrain, and all of the heights in the radius of the brush. Low is the same, except it just lowers. And then finally the color brush, which lets you paint with your picked color. You can see all the updates you've made show up in the height map. So you can export it and see this in a different tool or software. Finally, you have our file saving and file loading. You have the terrain file name and height map file name. So the height map is the image. You set the file name in here, where you just type whatever you want. So test name. You then export the height map, if you would like, and you choose the location. So I'll choose this. And you can also do that for the terrain, where you export the terrain. There you go. And so we could now generate a new map and load in the ply file that we've just made, which is test name and terrain file name. Here we go. So you have terrain file name here. That's the terrain we just made. You can see all of the details are there. And then load the height map image. Here you go. Test name.png. What you will have to do though, for when you save the height map, is sometimes the height values are a bit off. And what you might have to do is adjust them to recreate the terrain that you were loading. You might also realize it's a lot more jagged, or the height value is a lot more flat. That's due to the fact of the limitation of 8-bit integers, though in the next update that will be changed to 16-bit integers, and so you should have more control over the height values when you load in a height map. That's all.